1. Question: would you let an AI agent handle the gameplay for you for a game known as Minecraft? This is what Jim Fan, the author of the paper that we are going to look, has to announce. I'm excited to announce Voyager, the first lifelong learning agent that plays Minecraft purely in context. Voyager continuously improves itself by writing, refining, committing, and retrieving code from a skill library. Voyager rapidly becomes a seasoned explorer. In Minecraft, it obtains 3.3 times more unique items, travels 2.3 times longer distances, and unlocks key tech tree milestones up to 15.3 times faster than the prior methods or state-of-the-art or SOTA. Now let's look at everything this project has to offer. Now what I've decided is that initially I would like to give a brief introduction and a brief summary of this paper in just 5 to 6 minutes. And if you find the summary useful, if you want to learn the whole paper, then you can follow along with me for the rest of the videos. Alright, so let's get started. This is Voyager, an open-ended embodied agent with large language models. Essentially what happened is that we already had MineDojo, which is, it's a tool, it's an interface where you can build open-ended embodied agents with internet scale knowledge. It already has the internet scale knowledge. For example, MineDojo already has 730k YouTube videos with 2.2 billion words in English transcripts trained on these data, 7k wiki pages with interleaved text, images, tables, and diagrams, this data, and 340k Reddit posts with 6.6 million comments in Minecraft subreddit. So it has all the data. The MineDojo is already trained on these three data. But now what this paper actually did was to include or use the large language models, GPT-4 and GPT-3. So they have used GPT-4 to ask, to help MineDojo or to help the agent in deciding the next course of action. It's trying to replicate how a human would play the game. Let's see how much it was able to replicate. Now, again, Voyager is an open-ended embodied agent with large language models. Basically, it's an agent, large language models, and it knows how to play Minecraft. So these are different actions that the agent can take. It has three components. The first is an automatic curriculum that maximizes exploration. So the curriculum is like that. It wants to explore. So in this curriculum, it has a built-in prompt in GPT-4 that I want to explore this world. I want to learn new things. So that is one curriculum. The second is a skill library. Essentially, if you don't know how to play guitar, and now you know how to play guitar, essentially you store that skill somewhere on your mind, and whenever required, you retrieve that skill. It's not just like a boxy kind of retrieval in our human mind because it's very fluid and flexible. But in this case, they have tried to replicate. Whenever a skill is learned, they store the skill in the skill library, and whenever a new task is required, the skill is fetched or retrieved from the skill library to perform the task, And essentially the code is created by the iterative prompting mechanism. It tries to create the code, and after the code is created, a code for the skill library, particular set of skills, it is added as a new skill. If we have some heavy duty task, or if you wanted to do a very complex task, it will retrieve 3-4 skills as it deems fit. So these are the three methods: a desire for learning and exploration, a skill library, and an iterative prompting mechanism. See the results of this technique in this graph. On the x-axis, we have the prompting iterations in code generation. And on the y-axis, we have the number of distinct items which were discovered. We see for the React testing, there are very limited number of equipments or items that has been collected. Same is the case with reflection. But with AutoGPT, there are some elements which could be collected. With Voyager, without skill library, there are even more elements which could be collected. And with the Voyager, this method, you can see the maximum number of elements could be collected, maximum number of distinct elements. Also, if we look in the Minecraft tech tree, here the wooden tool is obtained very much earlier in the prompting iterations. Then the stone tool and iron tools are obtained very earlier, within 25 number of iterations. And even the diamond tool is also obtained in under 125 iterations. But the other methods were not able to obtain the diamond tool. So essentially, this is what technology has provided, what the large language model has provided. It has provided, a pathway to act like a human. So Voyager is the first LLM embodied lifelong learning agent in Minecraft that continuously explores the world, acquires diverse skills, and makes novel discoveries without human intervention. And just one more thing is that when we talked about this skill library is useful for the next set of games that you're going to play. For example, if you start a new session of the game, the skill library can still be used to conduct an activity. And this is like a human brain. Next, we look at automatic curriculum. So these are the inputs that goes to GPT-4, and GPT-4 spits out in the form of reasoning and in the form of tasks that we need. Now, this is just a summary of the automatic curriculum, but it has a very lengthy description of prompts, which I will go in the detailed description of this paper. But in this video, I'm just gonna have skimmed through this. Now, this is how the automatic curriculum looks like. The skill library, we store the skill in the form of a key and a value. The value is the program generated itself, and the embeddings is used and the key values stored. So each skill is stored as a key value pair. Now it is retrieved whenever you want it. You want to perform a new activity, we can retrieve that skill because we have the skills. Now it will search the skill library and it will retrieve the top skills that are required for carrying out a complex task. Now in the iterative prompting mechanism, on the second part where we created codes to store as skills in the skill library, so there will be errors when you try to create the codes. So some of the type of errors will be environmental feedback. So environment will give a feedback that, for example, I cannot make sticks because I need 2 more planks. I cannot make stone shovel because I need 2 more sticks. So such kinds of errors. And execution error. Suppose you know item named Acacia X. I mispronounced this word, but forgive me. So if you write if you want to create an item which doesn't exist in the gameplay, then we get execution errors, and environmental errors are obtained when there are insufficient number or any feedback from the environment as such. Now these errors are used by the iterative prompting mechanisms, and it will try to fix the error. It will try to fix the errors for 4 number of iterations, and if it fails, it moves to the next task. Now the experiments in the tech tree mastery, for example, we found that Voyager was able to obtain the diamond tool, and none of the other techniques were able to obtain the diamond tool. Extensive travel, map travel. So for example, the Voyager here was able to travel to a long distance. The React, Reflection, and AutoGPT were limited. Zero-shot generalization. So here in this experiment, they have just put the agent in a new field, in a new gameplay, and then found out what efficiencies and with what speed they were able to craft a diamond pickaxe, for example here, craft a golden sword, for example here. Here you can see that for all these cases, the Voyager is the top performing one. And if we compare Voyager with the skill library and without the skill library does improve the performance of Voyager. In the case of AutoGPT as well, we can see that AutoGPT without our skill library is this, and AutoGPT with the skill library is a pretty good performance, shows a pretty good performance with the skill library. Now ablation studies are the studies done by removing a single aspect or multiple aspect in the studies. For example, here this is the number of distinct items that is obtained, and if we remove the skill library, then the number of distinct items decreases. If we use GPT 3.5 instead of GPT-4, the number of distinct items reduces even further. If we use a manual curriculum, in the first, if you remember, we had out of the 3 steps we had an automatic curriculum or what to do. If we use a manual curriculum, manually coding the way the agent moves around the environment, then it's going to reduce the number of distinct items because we cannot possibly code everything up. And this is why we use GPT-4 and large language models to make it autonomous. So this is the perfect team that has created this beautiful project. And let me read the conclusion for you, and please tell me if you are interested in this paper so that I can give you, line by line, and in a more in-depth way we can make a discussion or have a discussion on this paper. So conclusion, in this work we introduced Voyager, the first LLM-powered embodied lifelong learning agent which leverages GPT-4 to explore the world continuously, develop increasingly sophisticated skills, and make new discoveries consistent with human intervention. Voyager exhibits superior performance in discovering novel items, unlocking the MineCraft tech tree, traversing diverse terrains, and applying its learned skill library to unseen tasks in a new instantiated world. Voyager serves as a starting point to develop powerful generalist agents without tuning their model parameters. So there you have it. This is Voyager. This is a wonderful paper. And please tell me if you're interested in learning the whole paper step by step. These are the codes. The codes are available. And in the next video, in the next to next video, we'll have a look at the code and we'll install everything up and run it in our system. We would need an open API key, GPT-4 and GPT 3.5 as well, for running this system. Now it's up to you. Over to you. So if you like this style of video, I would appreciate if you hit that subscribe button for me now. Thank you.